Alright, we're back again. I'm just actually going to continue on with, where did I put it? It's right here. This thing. So I just thought it'd be good to finish it up by coming to a conclusion about how it all works. This is actually the base unit. So this is the one that you plug into your old school TV and play Tetris with, and you plug this thing into here. So the plug goes, it's the batteries, I think it goes in there, so you plug the extra controller into there, so that's how it communicates with the main one. So very similar cases, this one's just a bit heavier. Right, so anyway, I just wanted to work out how with only 3 connections that you can get a fully working controller, and I tested it. I did play the game yesterday. I might do a video of me actually playing it at some point. Just checking everything's in the camera. Right, but today we're just going to go through. So I worked it all out. At first I was a bit confused because I thought I'd gone with my original way of doing this. So in this case here, there was a positive voltage that we were applying, and then we have a test point that we're sending back to whatever's using this, and we have a ground point. But you don't actually need this, because this part here can be within the main controller, so this part can be within here. So you only need 2 wires, two wires connected to use this kind of technique with the buttons. And also the point is, this one here doesn't care about whether or not you're pressing both buttons at the same time, because it's not actually possible to press both buttons at the same time. So if you look back at my very brief teardown, you'll see that there are 3 separate buttons, and you can't push any of them at the same time. So you can't push, like if you're pushing that direction, you can't be pushing the other direction at the same time. Maybe if you push down like that, it works. You kind of, well, we'll test, we'll see what happens if you do that. I don't really think that you could. You can push down. We'll try that. I don't think you can, but we'll try. But there's this and this. And when I did I got it kind of working, but I couldn't work out. Like when I did the rotating left and right, it didn't seem to change anything much. Like this, I could get, like, I read a voltage change when I moved in the 3 main directions, but when I tried to rotate, it was only being adjusted by about like 10 millivolts, which just wasn't enough, and it was very, very small. I'm like, oh, that can't be right. But then I realized that no, actually you only need 2 wires, and so because there's 3 wires on this, I think there's a separate connection for the up and down, or down, left and right, and then there's another connection for the rotate, and that's in fact what there is. And so what I came up with, so the first thing is, if you look at the end, I've kind of got it all set up, so I didn't really want to take it apart. You kind of need a bigger thing. I just realized I actually had a perfect thing to show you this, but it has 3 segments at the end. There's the little knobbly bit at the very end of it, and then there's 2 bits here. Like if you've ever looked at your headphones, that's what they look like. So it's exactly the same. This one's just a slightly smaller version. So when I looked at it, so I came to the conclusion that this is actually the common connection to both of them, and this is the one that's used for the rotate, and this is the one used for the direction, this part here. So you can just read the resistance values off, and they change as you do things, but I thought just to show that it works, I did actually do that, and I went through and I worked out what the different resistance values were, and so it looks like they're roughly like this. 8.3 is the resistance between here and here when you press that direction. I'm going to say that direction because that was right for me, but I'm pretty sure it's left for you guys. And then it's 15k for that direction, and it's 33k for that direction, which kind of makes a lot of sense, because I would expect there'd be some kind of doubling operation here. So this is roughly twice. They're roughly twice that. I'm pretty sure I roughly wrote these down, so they're probably not exactly correct. I don't know if there's a standard value. 33 certainly is. I went and bought a lot of 33 kilo ohm resistors today. In fact, I bought a lot of bizarre electronic stuff from. I didn't buy it. I just basically got given it, and I don't know what I'm going to do with all of it. But I think I'm going to get a fair good use out of a lot of it. giving it away basically. But anyway, here on the rotate one, which is between this point and this one here, so we'll just go back to here. Let me see it. It's so tiny, I should have just grabbed the bigger one. I can't get up now and do it. I don't want to get up and do it. It's a bit far away. But anyway, so between this point and this point is between this point and this point, so the two front ones, is the rotate. So if you read the resistance between here, it was 6.6 when you rotate that direction, and then it was 10k, 10,000. So this is 6.6. This is 6,600 ohms, and this is 10,000 ohms. That's 15,000 ohms. And when you don't do anything, it comes up about 33,000 ohms. And this one here, when I did the directions, like it was higher than my meter goes up to. So it was over 2 million ohms, apparently. So I don't really know the trick with that bit, but let's just show it in. So if you were doing this, you would probably be testing the voltage level, and so you have to add in another little resistor, which I did. So going back, so this bit here I'm adding in myself, and I chose, so because of the direction things, actually I should have just stuck with, they're all like the maximum one's 33. So what did I use? I've gone and forgotten already. I think it was something like, we better just test it. So if you haven't done the testing the resistance on your multimeter, it works like this. So my one here, it's down here. I'm pretty sure it's less than 20,000 K. And I'm just going to cheat. So I'm going to attach one end to this, and then I'm going to attach, that's not the best way of doing it. I'm going to have to change this around slightly. Alright, so I'm going to move this. So many cables today, and I think I've got every single light on, so hopefully you can see everything. So I've just measured them up, and what does it say? What did I use? I'm going to unplug this thing so it doesn't confuse it. And I didn't attach this. So I'm just cheating and using these banana clip things. These are quite handy. So it was 4,000, so it was about 4.7 thousand ohms. 4.7 thousand ohms. Yeah, that's right. 4.7 ohms. 4.7 K. So anyway, we'll go back to what it was supposed to be. So I'm going to attach that cable to there, and actually I'm going to rearrange everything. So I'm attaching the white one to the black terminal on here. So this is the negative, or the ground terminal. Common terminal, we'll use common because that makes more sense. So that's the common terminal there. Where are we up to? So that's just going to what my ground point is on this, or my negative rail. I really should get the terms correct. People are going to get very annoyed because I'm just jumping around the lowest point, and this is the other point. And then the resistor, it's very hard to tell. I'll just run out of things. Going to avoid zooming in. But the resistor is basically going from the positive rail down to here, and this one here is being attached to here. Oh, I've got them around the wrong way. Well, that was clever of me, wasn't it? Someone wasn't paying attention. So I probably got these actually the wrong way around, because I thought they were matched up to the same colors, and I just broke this. This is why I hate these wires. They are so rubbish. Oh dear. Alright. So that one's not going to work at all anymore. So that's alright, we weren't going to use black. So this one's actually going to the grey one. So if we look back, we'll go here. So I attach these up, and so the grey one is the end one. So hopefully this still works. So, well, there you go. I got them the wrong way around. So the brown one went to the black one, and the black one isn't even connected anymore. So this is going to be funny. These aren't the highest quality things, but they were the easiest things to use. Alright, let's just test this again. Maybe the ground one is actually the bottom one. Alright, so activate it. And we'll go back to voltage, sorry. And it's not working. So I got this the wrong way around. I'm pretty sure that was Maybe I did do this. So it should jump up to 5 to a different voltage level. If I had remembered to plug it all in, which I haven't. Alright, so we'll put that there and we'll put that there. What a mess! And we'll go to 20 volts. So right now it says 5 volts. So what have we got this connected to? We've got it connected to nothing. So the common one is in fact in the middle. So I'm going to put it there, and hopefully now, no, it's not. Okay. I have to think this one through. How did I do this? Let's just make sure the wires. Oh, the white one's not even doing anything. What a day! All right, let's try it now. All right, and try and turn. Okay, here we go. So I've actually connected it to these two. So I really got this all the wrong way around. That's what you get when you don't match the colors up on the end of these things. So these things here have holes and those ones have points. And I plugged them in, but then I used different colors. So that was a very, very, very silly mistake. So now my drawing is all wrong. Because I went, oh look, that goes to there, and then that one comes out the other side over there. But anyway, they're now connected up. So this is the movement one. So hopefully you can see that when I push one direction, the voltage changes. Let's turn the light on. The voltage goes to 3.2 in that direction. That direction. Back to 5 volts. And then that direction. It goes to whatever value. I'm looking at the screen. So that direction gives me 3.8 and that one gives me 3.2. That's not a very big difference. And that one gives me 4.38. It's not as exciting as I was hoping I could do. A better choice of resistor would probably give a nicer range of values. Because I've gone and mucked it up. Alright, we'll just swap them on over and hopefully we can get to rotate as well. Yay! So now when I swap this one, so I think actually, yeah, okay, that one's the common. So the bottom base bit is the common, and then the top one is the rotate. So I'm going to cross that out. So R, in my style, sorry, D, and C. That's the worst thing ever. But then, that way at least I know. So now if I rotate it, it goes down to 3.4, and if I go the other way, it goes down to 2.93, which is not so exciting. Again, a better matched resistor might make sense. Maybe I should have used a lower one or a higher one. But that's generally how it's but it goes to the middle. Oh, it goes to the middle, that's right, because it has a much lower off resistance than the other one does, which has a much higher one. So the voltage divider, we could probably do the maths. But because this one here, so the resistance, when you don't have anything, when you're not pushing in any direction, the resistance, the non-pressed resistance is like over 2 million ohms, and so pretty much all of the 5 volts is going to go through that. So in your voltage divider, this one's like, we'll make it 3 million ohms, and that one's like whatever you put it in. Maybe it's 10,000 K. I know it was 4.7 K, but this is where most of the voltage is going to go. So because we're measuring it there, at that point, should have drawn a diagram, then you're going to see 5 volts. Whereas in the other case, it's 3.3, so you've got, we'll do the actual thing. It's upside down. Sorry, 4.7 and 3.3. And the ratios of those two things, let's just do the calculation. Let's just see if we actually get 3.9 on. Alright, so we should be seeing 33 divided by bracket 4.7 plus 33 bracket equals, and then we'll multiply that by 5 and we get 4.37, so that's pretty close to what we're getting there. So that all sort of tallies up. So I hope that was kind of interesting and not too boring, but I just thought I'd finish it up because But the next project, after we finish my diode, my binary counter thing, which is over here, it's got a little piece of copper wire on it. So we're going to come back to this in the next video. If we don't get round to fixing this thing, which is my Sony Walkman, which does work, but you can hear it going, but it's not actually doing what you think. So, but that's giving away too much of what's going to happen. We'll come back and we'll finish this thing up. So then we've done diodes and resistors and all that kind of stuff, and then we're going to go on to more joystick fun. Yay! So anyway, thanks for listening, and I'll see you guys later.